First, we will demonstrate the various ways that both lower and upper joists and beams can be designed. Secondly, we will install and level a set of joists in a typical setup. Beams and joists are very much the same thing, and the term may be interchanged in some books. A beam is more often considered to be a heavier timber that will carry an intermediate point along the floor joist. This provides for larger clear span. A joist is a lighter timber with closer spacing. The loading of beams and joists is in two parts. One, the dead load. This is the weight of the material used. And two, the live load. This is the weight of the occupancy, people, furniture, or any other applied use. Most log buildings are started flat on the bottom, in such a manner that they could be set onto a flat platform or floor. In this case, the joists and beams are built into or on top of the foundation. Often the joists are placed on top of the concrete and extended to the outer edge. This is acceptable if the foundation is to be faced with rockwork. Otherwise, I would rather head the joist ends with a log. The next style of joist placement then is to place the joist on top of the concrete and then cut pockets into the first log. The joists do not need to extend all the way across the foundation wall, and give thought to which way the first half log is to run. If the logs are average size, 10 to 12 inch top, the half log might be on the side where the joist ends will be, example the long side, so that the end of the flooring might be notched into the side of the first full log. The next choice would be to use the first log as a beam, then seat the joists on top of this log. This style has two significant uses. One, the floor is raised to provide more headroom in a possibly low basement, and two, the first log or beam can rest on piling or posts when a basement is not needed. The required size and spacing of floor joists will depend on size and span. The vertical height of a beam is more important than the width, so two medium-sized logs placed one above the other may give better strength than one large log for a long span. The best size and spacing for both joists and beams can be calculated by use of a mathematical formula, or more conveniently extracted from engineering tables. From this table we can see that a 12-inch mid-span diameter log with a load of 120 pounds per lineal foot can be expected to span 28.4 feet. Span tables may be obtained from the Log Builders Association. Most importantly, avoid creating stress raisers where joists are seated. This is a condition created by sharp angles on the underside of the timbers. Good planning and careful log selection can go a long way to avoiding this situation, but if such a cut is unavoidable, try to round out the corners to help relieve point stress. Upper floor joists are most frequently made of logs, and we'll deal with the selection and placement of these timbers. The suggestions detailed here may also apply to the lower floor joists. When the desired wall height has been reached, you will need to place the upper joists for a second floor or loft. This height will most often be 9 feet or 2.7 meters. The walls don't need to be exactly the same height, but of course the closer they are to the same height the better. Snap a level line at a known height above the base and at each end of the building where the joists will be resting. This line is to represent the foundation line and is simply a convenient place to take measurements from. You can measure right from the foundation if that is more convenient. Now mark off the centers for the joist locations, then place the selected joist material up on these positions. If there is to be a balcony or extension to one end, you may want to place the large end of the log in that direction. Place the large end of the joist or beam accurately on your mark, then block it with rolling dogs. Shift the other end into place and dog that end also. Roll the log until the very best straight side is up, then dog it securely with drive dogs, only at the large end. Do this same operation with each joist. Now you are going to scribe the joist down so that the tops of each will be the same height above your reference line. To do this, place a level across the large end of what you judge to be the smaller joist. Measure from the bottom of the level to the reference line. Let's say this turns out to be 650 millimeters. Go to the small end of the joist and wedge it up until this end is also 650 millimeters above the reference line. Because your joist is 300 millimeters in diameter, and you would like to scribe it down about halfway, then choose a scribe width of 150 millimeters. This will leave the top of the joist 500 millimeters above the reference line when it is completed. Measure the height of each of the other joists at the large end, then raise the small end of each joist to match. Subtract 500 millimeters from the measurement at each joist, and the remainder will be the required scribe height. So the scribe setting for each joist may be different, but the setting should be the same at each end of one joist. When all your joists have been positioned and the proper scribe setting noted on the joist itself, set up your scriber and execute a double scribe. A double scribe means to place 2 pencils in your dividers and draw the upper and lower lines at the same time. The details for this is to be found on tape number 5, Other Notches, Part 1. Remove the joists from the building to do the cutting, and if you have suitable equipment, remove also the log on which the joist will be resting. Doing the cuts on the ground will speed up the work and increase the accuracy, but these cuts can also realistically be done up on the building. Here we are using a modified square notch. The outside shoulder is sloped to avoid any possibility of the joist retaining water. For some applications, you may want to use a blind notch on the joist or beam if you don't want it to show on the outside of the wall. These same procedures can be used for beams. Lower floor joists that are log and are to rest on a concrete ledge or pocket will be treated a little differently. First, square the end of the joist so that they are each the specified width and height. This might be 8 inches or 200 millimeters. Block up the central beam so that it won't deflect under the weight of the joists. Place the joist across the beams at its proper location and wedge or block the ends of the joist up until they are equal. Set your scribers to the amount that the ends must come down to contact the seat. Then scribe the joist at the beam. A square notch would be the most appropriate choice for this location also. Experience has taught us that it's better to cut the flats on the top of the joists after they have been fitted to the building. Here the end logs have been reset on the ground for convenience. When all the joists are in place, you can snap a line across the ends. The line should be equidistant from the foundation at all points. Again, it is best to remove the log from the wall to do the cutting. If removal is out of the question, you might build a scaffold and roll the joist to that spot. Roll the log until the line on the end is vertical, then snap an ink line on the side. Be careful to snap the line in the direction of the cutting plane. Roll the log 180 degrees and snap a line on the other side. Cut away the slab and be sure not to go below the ink line. Then brush or plane the joist right to the line. Now is the time to cut saddle notch scarfs on the top of the joists to accept the cap log. The cap log will be notched over the ends of the floor joists and most often flattened to accept the roof structure. Use good, clean, straight logs for this position so that you can get a scribe line that is easy to see. The multiple notches in this log will test the skill that you will have developed as you built the walls. Work very hard to obtain the required fit on the first operation, because adjusting and refitting this log can become a little frustrating. If you have removed the top logs of the wall to the ground in order to fit and level the floor joist, take this opportunity to set, scribe, and cut the flat on the top of the cap logs. If your building is large and the cap log long and heavy, it may be a good idea to block the setup at the center to keep everything in line. Cutting the notches for this log is a satisfying experience. You may decide to use saddle notches, round notches, lock notches, or sheep's head notches. Any of these can be suitable, and whichever of these you choose, a benchmark in the project has been reached, and this nice symmetrical row of notches will confirm your ability. The joists are finished, but you will want to cut a seat in the cap log and plate logs for the side and end of the flooring. For the plate logs, these lines might be located and cut along with the joists. The recess on the cap log might be located from the top of the scribe line and completed on the ground after the notches are cut. If there is any suspicion that the cap log might have to be adjusted, it may be better to replace the cap log and complete the layout after the fit of the notches has been confirmed. Also, you will lay out the flat for the top of the cap log, and if you take the time to check the location of the center lines and square of the building, you can also cut the mortises for the roof structure while this log is on the ground. If you are using an outrigger plate, treat the top log of the wall as a joist and flatten it also. Alternately, the flooring can be notched into this log, then continued on the other side. It is also an option to space the joist wider and use them as beams. In this case, you would cut a wider recess at the plate log and cap log to accommodate dimensional joists and ceiling, as well as the flooring. A recess for the ceiling material can be dadoed into the edge of the beam or a furring strip secured to the top. If the ceiling is to be decked with a planking material such as 2x6 or 2x8 tongue and groove, it can be an advantage to make a groove for electrical wiring. If you are going to run additional joists, the wires can be run between these. Because these logs are handled several times each, it is recommended that you use slings to avoid excessive scarring of the logs. A soft grapple of a suitable size range will also provide this advantage for the whole building. Your floor joists are now all in good order and no additional work should be necessary. This is an occasion for a modest celebration. We can have a major celebration after the roof support system has been put in place. There are many possible ways to build a post and purlin roof support system. The procedures demonstrated in this video have proven to be very serviceable, as well as being quick to build and efficient to move. We will imagine a gable end roof that has a span of 5 meters and a 1-to-1 slope. The plate log will be as straight as possible and in place with a preliminary notch. The height of the plate log will be close to equal on all 4 corners of the building. Check the location of the center line on the top of the plate log and square the building. If reference marks were placed on the bottom log at the time the building was started, these marks can be extended to the top log and an accurate location found. Ideally, the plate log will be set out a very little at the top end, 15 millimeters, and a very little in from the center line at the large end. The length marks of the wall should match the center line on the gable end wall, and these intersection points should have diagonal measurements that are within 5 millimeters. If the diagonal measurements are not equal, some adjustment of the center lines should be possible. If your work up to this point has been kept under careful control, these points should be easily established. If there are any questions, check all the measurements.
That's good. Okay on 100.
Snap a center line on the plate log and drop plumb lines from each end. Locate a height mark on each of these plumb lines that is equal distance from the foundation line. This height mark may be a little above or below the top of the plate log, as long as the slope line of the roof intersects the plate log and provides an adequate flat surface. If the plate log extends out from the wall for a long overhang, use a straight edge and a level to locate the height measurements. A transit or level set on top of the building can simplify this operation. The roof slope can be drawn on the log end either up on the wall or after the log has been removed from the wall. A template can be made to make this layout simpler. Cut the roof slope or pitch cut and replace the plate log. This cut may be done by a sawmill or by hand. Now lay out the cap log. The cap log will be located on the center line of the end wall and fitted over the plate log and upper floor joists, or it may be under the plate log, depending on the design requirements. Use a square notch or a lock notch. Most builders cut the roof slope on the end of the cap log. I feel this is incorrect, and I always extend this log out to the top of the rafters to prevent the inevitable separation of the notch at the plate log. Putting the plate log on top of the cap log will also solve this problem. you will want to make a flat cut on the top of the cap log. This flat can be almost any height as long as it is sufficiently above the notch, let's say 100 millimeters. But the plate line that you snap on the cap log should be the same height as the line you located on the plate log. If this or any flat cut is to stop part way, make the end cuts first to avoid overcutting. Replace the cap log on the building and start work on the ridge and purlins. You might cut the cap log mortises on the ground. Our object then is to position the ridge and purlins at the specified height and location. If the span is 5 meters and the slope is 1:1, the top of the ridge will be 2.5 meters and the top of the purlins will be 1.25 meters. Because we have a flat on the top of the cap log, it is only necessary to determine the height of the post that will support the ridge or purlin. Let's demonstrate this process with a post for the ridge log. Choose a suitable ridge log. A large straight log is the usual choice. Position this log on blocks with any bow up and snap a center line on the top. Draw the slope of the roof on the ends. The apex can be a little above or below the top of the log. Place a level reference line on each end, equal distance below the apex of the slope. This line can be at any height, but an even number will be easier to remember, say 200 millimeters or 250 millimeters. Place lines and do the slope cuts, then roll the log onto its side so that you can snap lines vertically down the length of the ridge for the reference height line. Turn the ridge log over so that the peak is down, then snap a center line on the bottom of the log. Use the plumb lines on the ends to ensure a vertical position. Locate the post centers on this center line and cut a flat across the log that will be 100 millimeters or 4 inches wide and the same length as the width of the post you choose for that location, perhaps 250 millimeters, 10 inches. Lay out and cut the mortise for the post, 100 by 100 millimeters, and on the center line. This mortise should be 100 millimeters deep. Prepare the post logs by flattening them on each side to a width that will be equal to the framing material plus the sheathing to be used, let's say 150 millimeters or 6 inches. The width of the post itself can be a random measurement. Make sure that the post is long enough. From center lines, place a cut line around the top of the post about 100 millimeters from the end. Use the two squares to obtain an accurate layout. When the tenon has been cut and checked with the template, lift the post into a vertical position and enter the tenon into the mortise. Secure the post in a vertical position that is 90 degrees to the reference line. You can use a level to check the end center lines and a 3-4-5 triangle to position the side center line with the reference line. You may also use a plywood right angle triangle to hold the post in place. Scribe the post to the ridge log, then take the post down and cut out the segments indicated. See tape number 6 for additional details about cutting a post notch. Reposition the post and check the work. The post may be left uncut and a circular segment cut from the ridge instead. This would be a second choice for me. With the fitted post in place, mark the width of the flats on the ridge log so that a plumb cut can be made for the gable end framing material. The slot will be the width of the framing material plus the thickness of the wall covering on each side. When the post has been fitted to your satisfaction, measure the length from the reference line and place an identifiable mark on the side of the post. This mark will be 2,500 millimeters, less the height of the reference line and less the height of the flat on the cap log above the plate line. If the reference line is 250 millimeters from the apex of the ridge and the flat on the cap log is 100 millimeters above the plate line, then the length of the post will be 2,500 millimeters less 350 millimeters, or 2150 millimeters long. Cut the end of the post about 150 millimeters longer than this measurement to allow material for the bottom tenon. Lay out and cut this tenon the usual way, and this post will be complete. You may wish to dado grooves on the flat side to make a better housing for the sheathing when the structure is finished. The post for the purlins will be treated in the same way, but instead of the apex of the log, you can dimension your height from the intersection of the center line and the slope line. The simple mortises on the top of the cap log can be cut on the building. Unless there are unusual circumstances, these 3 mortises will be positioned on the center line at the middle and quarter measurements along the cap log, much like the tie beam for a truss. This simple roof structure may now be put in place on the building. This is best accomplished with a crane or hydraulic lift truck. If you do not have access to either of these, there are a number of other devices or procedures that can be used. As each post is positioned, make sure that it is vertical and securely braced so that when the ridge or purlin is placed on it, it will not be in any danger of falling. Use slings or straps that are shackled to the lift hook so that there is no danger of losing the ridge piece. When this assembly is in its permanent position, the plate logs and cap logs will be drilled and drift pins driven into the next 2 rounds of logs. There are usually enough window and door locations along with the through bolts at the corners to meet the standard requirement of 1 fastening every 2 meters, so use these as much as possible. In preparation for the common rafters, nail a strip of wood, 1x4, to the top of the plate, purlin, and ridge logs that will lift the rafter the thickness of the ceiling material. This will greatly speed up and improve the quality of the ceiling application. Alternately, this step might be rabbeted into the beam before it is put in place. This will be a little stronger, but a lot more work. Next, prepare the end of the cap log by cutting it flat on the sides, with the step on the bottom to allow the soffit material to be entered. Common rafters of the design dimension are put in place. They may be notched over a cleat on the plate log or secured with metal nailing clips. These rafters should be pre-cut, and the work will be easier if the rafter positions are marked on the beams before the ridge and purlins are hoisted onto the building. Leave the lower end of the rafter a little long so that it can be trimmed after all the rafters are in place. This will make a straighter eave line. Provide backing for the ceiling material at the gable end. Put 1 rafter on each side of the cap log and nail a 2x2 flush with the outside edge of these. You should have eave blocking between the rafters at the plate. The eave block should be a size smaller than the rafter to allow ventilation over the insulation. For example, a 2x10 rafter, use a 2x8 eave block. Use an ink line to mark the ends of the rafters, then use an electric saw to make the plumb cut. Nail the eave board to this. Cut and fasten the barge boards at the ends, Then nail your choice of decking. The decking may be 2x4 nailing strips for shakes, shingles, or metal roof, but the space from the end of the rafter to the plate log should be completely decked over. A great variety of materials can be utilized here. Your choice should be made at the design stage. Another board should be placed on the top edge of the barge board to cover the end of the decking. Flashing placed over this, and then the roof itself. Cedar shakes are a romantic investment, and they will stand up well on a steep roof that is well ventilated. On a shallow pitched roof, you might be better off to use synthetic shakes or metal roofing. Concrete or clay tile is good, but also should be used on at least a moderate slope. The roof is on. Your work will now be out of the weather. You now have some choice of which work you will do next. You may choose to put in doors and windows and bring the house to lock-up. You might do the electrical wiring, the roof insulation and finishing while the house is still ventilated. Either way, we hope you are moved in and comfortable before winter.